So this is lecture number 8 on heat and thermodynamics. Do you recollect what we had done in the previous class? Fatafat, let me know what we were doing in the previous class.
Buoyancy force.
Okay, we had a brief discussion on buoyant force, and we were seeing the expansion of liquids, right? We were dealing with expansion of liquids. Am I correct?
Yes, sir.
Expansion of liquid, and we had seen two types of expansion of liquid. What were the two types? Or we had seen two coefficient of expansion. What were the two coefficient of expansions? One was gamma L and one was gamma A. What was gamma L? This gamma L was coefficient of real expansion, and this gamma A was
Aerial expansion.
aerial expansion. How can liquid expand aerially? See, that means you are not paying attention in the last class. You have not revised. See, beta, I'll give you a piece of advice, and that is the most important piece of advice you will get in your life. If you come to any class, whether it's physics, maths, chemistry, biology, anything, if you, before the class, last night or before the class, if you don't revise what we had done in the previous class, and if you don't remember anything from the previous class, this class goes away. The significance of this class is no longer there. And if you still can't get into that habit, well, it is a very dangerous sign for you. Your exam is coming and still you don't have this habit. This is a crime. You are committing a murder. You're committing a murder of your chances of getting into an IIT. You're committing a murder. So gamma L was coefficient of real expansion and gamma A was coefficient of gamma L was coefficient of real expansion. See, you still don't remember the term. May God help you. I pray to God to help you. Apparent expansion, and this was equal to real expansion minus the expansion of the solid or the container in which the liquid is kept. Does it ring any bell now?
Yes, sir.
Very dangerous sign, beta, and I don't appreciate what you are doing. If you don't remember the terms, maybe I can give you a, maybe you don't remember this gamma L, gamma A that I use as a gamma A, but still you must remember that there is a real expansion coefficient and there is an apparent expansion coefficient. Please don't forget it, else the entire exercise that we are doing here is futile and there is nothing useful going to come out of it. Anyways, we have done this, and I promise you that we will be solving a couple of problems for you to make any sense out of this. So let us do one or two problems. I hope after these problems you might be remembering it better. So here comes problem number 1, and I hope that you are able to solve this. Again, you get only one chance to look at the problem, and in that one chance you must be able to understand the important points. A glass flask of volume 1 liter, so the volume is 1 liter, at 0 degrees Celsius is filled. Did we do this question? I don't know. Okay, is filled of mercury at this temperature. The flask and mercury are now heated to 100 degrees Celsius. How much mercury will spill out? I don't know. It just looks like we have done this question. Okay, the volume expansion of mercury is given as this. Remember, liquid expands a lot more than solids. Linear expansion of glass is given as this. You have to find out how much mercury will spill out. Can you do that for me? how much mercury will spill out if you heat this vessel, this flask, together with mercury. I'll give you a minute to figure this one out. So, how will you find out the volume of mercury that will spill out? Anyone got the answer? And we had done this formula, I think, exactly in the last class. So the volume that will spill out will be V into gamma L minus gamma S, or gamma of the container, multiplied by delta theta. Do you remember this?
Yes, sir. Aya, sir.
Aya? Hello, Aya. So congratulations to everyone. Gamma L minus gamma S. This gamma L minus gamma S is known as? This gamma L minus gamma S is known as?
Apparent expansion. Gamma A.
Gamma A, which is coefficient of apparent expansion. Well done. Well, now I can make a variation of this question, and the variation is pretty simple. So what I'll do is I will write this question as a question, and then you will solve it as a question. Okay, so the question goes like this. And how does the question goes like this? And I'll just write it. A vessel of volume V and gamma instead of gamma I will write alpha S. Do you understand the meaning of alpha S?
Yes, sir.
Okay, I will not say anything. I'll just write
Coefficient of linear expansion of solid.
What?
Coefficient of linear expansion of solid.
Good. A vessel of volume V and alpha S is having a liquid of volume V by 3. So I am not completely filled it up. Has a volume of V by 3 and gamma L. It is heated. To a temperature, and change in temperature is delta theta. And here I am assuming that this delta theta is enough to make the liquid spill. Find the amount of liquid spilled. Do you understand the question? Find the volume of liquid spilled. I hope you can understand the difference between this question and the previous question. What is the difference? What is the difference in the two questions? Apart from my giving the question in terms of V, alpha, and theta, they had given the values. That is not the difference. What is the difference between this question and the previous one? Tell me. If you don't understand the difference, you will not be able to solve the question. Do you understand the difference?
Delta V given, sir.
Yes, bacha.
Delta V is given. We have to find V.
No, that is not the difference.
V naught.
That is not the difference. You have not read the question correctly. Read the question again. That is not the difference between the two. That is not the difference between the two, and that is what you must understand, bacha. We have a very little time, and in this very little time, we can do a very limited amount of questions, and those questions should cover the entire spectrum. If I change a bit in the question, this is not maths. This is not maths. If I give you integral of sine theta d theta, it's a simple thing. If I make it sine square, it becomes difficult. If I make it sine cube, it becomes more difficult. If I make it sine square, sine raised to the power 4, it becomes still difficult. Just changing from raised to the power 1 to 2 or 3 or 4 makes a difference in math. It does not make such a lot of difference in physics. I just change some values here. That does not become an entirely different question. The concept remains same. In maths, The entire process may become different. The way you integrate sine theta d theta, you just write the answer. But when it comes to sine square, you will have to convert into double angle, and then if it comes to sine cube and triple angle, then sine raised to power 4, then you to square it, and then get into all sorts of jiggles. That is why you need to do a lot of problem in maths. But in physics, no, one problem should be good enough. If you don't understand the difference, I'll again show you the problem then. I'll again show you the problem. You don't listen to what I say. Again, a very, very dangerous sign. You don't listen to what I say. You don't read the questions correctly. This is committing daylight robbery. Not maybe a murder, but this is daylight robbery. This is the question that we were doing. A glass flask of volume 1 liter at 0 degrees filled, level full of mercury. Full of mercury. The small letter is the difference between this question and the question that I have given you. Still you don't understand it? That means you don't read the question carefully. A very, very dangerous sign. This is not maths, bacha. This is physics. This is not chemistry, bacha, that even if you don't read the question, you will be able to solve it. This is physics. A very small term makes the question different, but that does not make the process of solving the question different. Do you understand the difference now? Yes or no?
Yes. Yes.
What is the difference? Tell me. What is the difference? Tell me, bacha. What is the difference? Still you can't understand.
Only V/3 in this question, sir.
Yes, there is V/3 in this question. That means I have made a question where milk is getting boiled in a container, and milk, obviously I'm not stupid enough to fill the milk up to the top, because if I fill the milk up to the top, we will not be able to boil it, because as soon as it's boiled, it will just come down. So your mom or your dad, whosoever is, or your servant or maid, whosoever is boiling milk in your house, does not fill the milk up to the top. He will just keep some space. That is the space. V/3, I've only filled up to V/3. Now how much milk will spill out? And I've told you that this change in temperature is good enough to make the liquid spill out. Can I have any answers now? If you have understood the question, the answer should be coming just now. Shall I solve it? If you have given up? Well, I can't give you infinite time because I don't have that liberty. Yeah, anyone with an answer? Girls, boys? It is not a different question. It is not a difficult question. It is as simple as it gets. How much volume will spill out? It's very simple. No one? Well, I must move on then. Then what do I do? We have a vessel of volume V, and inside it we have a liquid of volume V/3. So the final volume of liquid, or let us say final volume of the vessel. What is the final volume of the vessel? Tell me. What is the final volume of the vessel? You can't tell me the final volume of the vessel? You can't tell me the final volume of the vessel? No one can tell me the final volume of the vessel? Sad. Anyway, the final volume of the vessel will be V, the initial volume, into 1 plus gamma L delta theta. We all agree on this? Yes or no?
Sir.
Okay, we all agree on this. And what is the final volume of the liquid? What is the final volume of the liquid? Oh, in the vessel I have written gamma L. Oh, I made a mistake unknowingly. This cannot be gamma L. This would be how much? 3 times alpha S. Do we understand this?
Yes, sir.
Okay. What is the final volume of the liquid? It should not take so much time, bacha. Yeah.
V by 3 into 1 plus
V by 3 into 1 plus
gamma L into delta theta.
gamma L into delta theta. How much volume has spilled? How much volume has spilled? If I call this as V1 and if I call this as V2, how much volume has spilled? Come on, this is not physics, this is common sense.
V1 minus V2.
Think again. V1 minus V2 or ulta? The volume that has spilled will be V2 minus V1. Do we get this? Final volume of the liquid will be more than the final volume of the vessel. Do we understand this?
Yes, sir.
Was it so difficult for you to do this? Was it so difficult for you to do this? No, there was no physics involved. Physics was only involved. Physics was only involved in this formula, this one and this one. We already have the knowledge of these two formulae. Then after that was common sense, no physics. Physics is common sense actually. And common sense is physics. Common sense is not chemistry. Definitely not chemistry. Common sense is physics. Physics is common sense. You subtract these, whatever answer you get is your answer for the liquid or the volume of liquid that will spill. Do we understand this?
Yes, sir.
Please note it down and do not forget this. We only have one chance to live our life. We only have one chance to give our exams. That is how you must think. Give it your best shot. Prepare yourself accordingly. Prepare yourself accordingly so that you don't regret whatever happens in the examination hall. If you try your best, you will not regret. If you don't try your best, then you might regret it. I never regretted my rank. I could have reasons to believe that, oh, I didn't tell you, I cleared JEE in the year 1996. My rank was 3,800. Then I attempted again in the year 1997. 1997 is the year where JEE got cancelled because of a paper getting leaked out. So we had two papers in 1 year. One paper was out. The other paper was the main paper. The paper which was not out, which got out, I gave it with the best of my abilities. And if that paper would have not been out, I would probably be landing up somewhere in top 300 of the country because that paper was so good. But then between paper 1 and paper 2, the paper which got out and the paper which eventually happened, there was a gap of 2 months. that 2 months I did not study. I was like, oh, I'm good enough. That is why my rank went down to 1826, and that was my final rank. I don't regret it. I gave it my best shot. Yeah, probably in those 2 months I should have studied more, and probably my rank instead of 1800 would be somewhere around 800 or even less. But I don't blame it on anything. I blame it on myself. I had given it all hard work. I could not have done better. I could have given IIT one more time, because in my times there was no limit on the number of attempts that I could have given. But I said, no, I've done enough and I can't do better than this. Maybe in the third attempt I would have got into top 200 or 300 as also. But then I thought, no, I worked enough. If that is your case, you think that you have worked enough, well done. But I don't think that you have done that. That is how you will improve. And this is the question that you're going to improve. Question number 13. These are the type of question that you will see in your examination hall. The absolute means the real one. So you can have different terms for it. The absolute expansion coefficient of a liquid is 7 times the volume expansion coefficient of the vessel. What is the ratio of absolute and the apparent expansion? Your turn to give me the answer. What is the ratio of absolute, matlab real, and apparent, means apparent expansion of the liquid? And the answer is
7:6.
so I don't need to explain it. That is self-explanatory. Then comes probably the most difficult question, or one of the most difficult ones that you can encounter in this. I think we have already discussed this in a different way. Here comes the way that it might appear in an examination hall. A solid whose volume does not change with temperature. So this is given. This volume does not change with temperature. Floats in a liquid. Well done. For two different temperatures, T1 and T2, remember, the question would not be straightforward. They would ask you in a random way. At two different temperatures, T1 and T2, fractions F1 and F2 of the volume of solid remain submerged. What is the coefficient of volume expansion? Your time starts now. So I can make this question more difficult by making the liquid as well as the solid expand. Doesn't matter. We have already seen the buoyant force on this liquid, the buoyant force on this solid. I've given you the formula for that one as well. From the same phenomena, from the same concept arises this question. Can I have answers, please? And again, it comes from whatever we have done in the previous class. If you don't remember it, then you might not be able to do it. Yes, Becha, tell me the answer. Anyone? Okay, I'll give you a minute to think about it. Think. Give me the answer.
Sir,
Yes.
just wait, sir.
Yes, I'm giving you time. Don't worry.
F1 minus F2 by F2 T1 minus F1 T2.
I think that is correct. So I think the correct option is option A. Is that so?
Yes, sir.
Yes, I think it is option A. Yes or no?
Yes, sir.
Well done. How did you do it? That is the next question. Sometimes you may get a correct answer by a concept which is not correct. Okay, tell me, how did you do it? Remember, the volume of the solid does not change.
V equal to V naught into 1 plus gamma T1.
What is V naught?
Sir?
What is V naught?
Volume.
Volume of what? This V naught. What is this?
Volume of liquid.
Volume of liquid what?
Floats on
Volume
of solid. That means.
Volume of solid. Which volume of solid?
Inside the liquid.
At which temperature?
T1.
No. Okay. Now, I could do this question in a variety of ways. I could do it by the density wala concept. Right now, since I have limited space here, so I'll just do it with the volume wala concept. So what is this V naught? Now, there are some temperature where this liquid is floating. We call that temperature as T naught. Do we understand this?
Yes, sir.
We call this temperature as T naught, and this temperature, at this temperature T naught, V naught volume is inside, or V naught volume of the liquid is displaced by this solid. Do we understand this?
Yes, sir.
So this is at temperature T naught, some temperature T naught. Now when the temperature becomes T1, the temperature becomes T1, the volume of the liquid displaced will become V naught into 1 plus gamma T1. Yes or no?
Yes, sir.
At temperature T2, the volume of displaced liquid will become V naught into 1 plus gamma T2. From here, you can just divide and get the value of gamma, and the value of gamma is F1 minus F2 divided by F2 T1 minus F1 T2. Do you understand this?
Yes, sir.
Everyone understands this?
Yes.
Can I have some raise hand? Yes, sir, we understand this.
Yes, sir. Understand.
Okay. Then what we do is, we move on to discussion. Again, remember, the question could be asked in a variety of ways, but the concept of solving the question remains same. And here comes question number 9. The coefficient of apparent expansion of a liquid in a copper vessel is C, and a silver vessel is L. The coefficient of real expansion of expansion of copper is YC. Volume expansion is YC. What is the coefficient of linear expansion? So there are different terms. For copper, it is given volume expansion. For silver, it is asked what is the linear expansion. Your turn. Your turn of solving it. So we have a liquid. The apparent expansion in copper is C. Silver is S. Volume expansion of copper is gamma C. What is the linear expansion of silver? And the answer is, we have options A, B, C, D. Don't guess. Don't look at the answer and try to find out an answer. Solve the question and get the answer.
C plus gamma C minus S by 3.
C plus gamma C minus S by 3. So that means this is option C. Is it correct?
We got that answer.
Okay, so how do you get it? We know that apparent expansion is gamma L minus gamma solid. From there, you can find out the actual expansion coefficient, gamma L.
Apparent plus gamma S.
Then you just put the values and you equate the value of gamma L from both sides. So gamma L from one side is C plus gamma copper. Gamma L from the silver vessel is S plus gamma silver. From here, you can find out the value of gamma silver. You divide it by 3, you will get the value of alpha silver. And your answer, I think, would be option C. Do we understand this?
Yes, sir.
Everyone has noted this down?
Yes, sir.
That takes me to the next problem. And the next problem goes like this. And this problem has come in JEE. So this problem has come in JEE. Okay. Now we have discussed this problem. So remember, the way we discuss it, sometimes the same way, same language, the problem will come. Sometimes they may change the language, and that is what it is hearing. That is what is here. A body is afloat inside a liquid. How they trap you this way. If you don't know the fundamentals, you are trapped. A body is floating inside a liquid. Oops, why this is happening? Because I have not done this. I'll do this. A body is floating inside a liquid. Now remember the question. Listen to the question. If we increase the temperature, then what changes occur in the buoyant force? So I increase the temperature. What happens to the buoyant force? Buoyant force, buoyant force. Buoyant force increases, buoyant force decreases. Buoyant force remains same. Cannot tell what happens to the buoyant force. Data is insufficient. These will be the 4 options that you will have. Buoyant force increases.
Buoyant force remains same, sir.
Buoyant force remains same. Who? That does not look like a good answer. Correct answer. Okay, tell me why it remains same. There must be a reason. The reason is physics and common sense. Physics is common sense is physics.
It doesn't change upon temperature while gravitation force is acting downward.
Buoyant force is acting downwards. It does not change. Oh,
Gravitation force is acting downwards, sir.
what is acting downwards?
mg, sir.
Mg is acting downwards. Okay, so
It doesn't change upon adding temperature.
Mg doesn't change upon changing temperature. Okay, got it. Then how does it make the buoyant force constant? Don't read the answer that is given here.
B equal to mg.
Yes, this buoyant force, if the body has to remain afloat, I told you the only condition in which the body can remain afloat is when the buoyant force equates the weight of the body. That is the only condition of floating. When I change the temperature of the body, does the mass of the body change?
No, sir.
No. Density changes, volume changes, but the mass remains constant. The value of G also does not change, so the weight does not change. If the weight does not change, the buoyant force has to remain constant. Remember, it was said, assume that the body is always in the floating condition, and hence, the buoyant force remains constant. So don't get confused. I hope it is clear to everyone.
Yes, sir.
These are the type of questions that you will encounter. And then the reason is also given. By increasing temperature, density of the liquid decreases, so the volume inside increases to keep the buoyant force constant. That is the reason. We have already discussed the reason. Then comes the next question, which is related to the previous one. In the previous question, discuss the case when body moves downward, moves upwards, and remain at the same position when we increase the temperature. So this is a question that comes many a times. What happens? Does the body go down? Does the body go up? Or does the body remain at the same level? When will this happen? When does this happen? That the body goes down? That the body comes slightly up? Or the level remains same? The baton passes on to you. I hope you understand this. I'll give you a minute to think about this.
Sir, it remains same.
In all cases,
It remains same, sir.
the question is, discuss the case when the body goes downward. So you have to tell me, when will the body go downward? When will the body move upwards? And when will the body remain at the same level? And that answer you are giving me is the body remains at the same level, which does not make any sense, bacha. It's not making any sense. Yes, Betty, tell me. What do you think? If you tell me, when does what happen?
Sir, it remains at the same position if volume VL is less than VS.
VL, I think, is the volume of the liquid displaced that you are talking about.
Yes, sir.
And VS is the volume of the solid that you are talking about.
Yes, sir.
No, it's not making sense. The volume of the liquid displaced is always less than the volume of the solid. The only case where the two become equal is when it is just floating or when it is submerged. That your answer does not answer any of the questions, so you must try again. VL, the volume of liquid displaced, is always less than or equal to VS. It cannot be more than VS in any case, bacha. In any case, it does not remain same. And okay, so you are saying that since VL is less than VS, the body remains at the same level? No, that is not the correct answer. If that is what you meant, that is not the correct answer. You must think harder. And you must think, see, if I give you the answer to every question without you even using your brains, you will have to remember everything. And I'm not very confident about the remembering part, because this remembering part of the brain, it will always deceive you. It will always leave your hand when you need it the most. And you would have seen it in an examination. All you, oh no, yaad nahi aa raha, I can't remember it. The remembering part of the brain is like a unfaithful girlfriend or boyfriend. It will always leave you. The understanding part of the brain is like your wife and your spouse, never leaves you. So remember that. Understand rather than remember. I give you a minute on this thought, not on the thought of girlfriend, boyfriend, and wife, but on the thought of what happens here. And I need to have an understanding from your side how it happens. If you understand this, well, wallah, this is the most difficult part of this chapter. Minute to win it. And if you can solve a physics problem without using a pen, you are exceptional. I don't think you can do this with this one without using a pen. So better use your pens and your brains at the same time. Probably you can do calculations in your head, but you have to reach the stage when you can do the calculation part. Please do it. I'll give you a minute. I want you to do this so that this remains a part of your life forever. This will encompass everything about buoyancy that you will ever encounter in your life, in the exam, I mean, and everything about the volume expansion of liquid, and things will become crystal clear in your head, and they will never leave your sight. Like your mom and dad, they will always be with you. Your wife, spouses, husbands. Children never are with you always. They'll always go. Chalo. Anyone with an answer? Enough of philosophy.
नहीं आ रहा सर, एक बार एक्सप्लेन करो.
Yes, sir. Kya?
Not getting answer sir.
Think. Not thinking hard enough. I'll give you more time. I can explain it, but my explanation, you'll try to remember it. That's the problem. I'll explain it. My job is to explain, but you give up too easily, and that is the problem. If you give up so easily, that is not a good sign. You should not give up so easily. So I'll give you a hint first of all, and the hint is this part. You will have to look at this part. What happens to this part? This is not a hint. This is common sense. This F, small f, stands for the volume, the portion or the percentage or the ratio of the volume that is submerged. So this is the volume of the body submerged inside the liquid divided by the total volume of the body. Depending on this factor F, you can tell whether the body goes down, whether the body goes up, or whether it remains at the same level. This decides everything. So that is the only thing that you had to think. If you could not think it, no problem. I have given you the hint. This is what physics and putting your brains is all about. Now you have to find the ratio of these two things. Can you find the ratio of these two things? Yes or no?
Yes sir.
Yes. Then you will have your answer, my dear friend. And you will not have to remember it. Because there is nothing that you should remember here. It's all common sense. Common sense is physics. Physics is common sense. Again, I'll give you a minute to get me the answers. Okay, I'll help you out. So in first case, I find the fraction of volume which is submerged. This is at temperature θ1. The volume submerged, the ratio of volume submerged is V1, initial volume submerged, divided by V0, the initial volume of the solid body. Do we understand this? At temperature T2 or θ2, the fraction of the volume becomes F2. Now this F2 is the new volume V2 of the body which is submerged, the portion of the volume which is submerged, divided by the new volume of the solid. Do we understand this equation number 1 and equation number 2? Yes or no?
Yes sir.
That's it. For equilibrium, weight should be equal to buoyant force. Yes or no? We all know this.
Yes sir.
And buoyant force is volume submerged into density of the liquid into G. Yes or no?
Yes sir.
That is should be equal to V1 into D1 into G. That should be equal to V2 into D2 into G. Yes or no?
Yes sir.
Now it's all maths. Physics finish here. I hope you understand up till here. So from here, I can find the value of V2. V2 will be V1 into D1 divided by D2. But we know that D2 will be equal to D1 into 1 plus D1 divided by 1 plus gamma L into delta theta. And that will become V1 into 1 plus gamma L delta theta. And this is the formula that we used in the first question. Remember that question where you use V0 into 1 plus gamma L delta theta? Remember that?
Yes sir.
So this is how it is derived. This is how it is derived. This is how it is derived. So you know V2 will be equal to this one. So you could have straight away used that formula, bacha, and you could have got your answer. So from here, I get the value of F2. Do you understand this, the value of F2? This is the volume, the part of the volume submerged at an increased temperature. Can I have some raised
Yes,
hand that
sir.
we understand this?
Yes, sir. Understand.
This is the initial fraction of the volume submerged. Can I have some raised hand that we understand this?
Yes, sir.
Now you have to find out whether F1 is more or F2 is more. That is all about maths. And that will tell us whether it will go down, it will come up, or it will remain at the same level. I'll give you a minute to tell me when it will go down, when it will come up, and when it will remain at the same level. You know what is F1, you know what is F2. Please do the last step for me. And remember this F1 and F2, if you even don't understand it now. When does it go up? When does it come down? And when it remains at the same level? Anyone with an answers now? Compare F1 and F2. When does F1 and F2 remain same? When does F1 become more than F2? When does F1 become less than F2? Come, you can do this. Come, bacha, tell me. Till I have some water.
Sir, F1 is equal to F2 at gamma L equal to 3 alpha 2, 3 alpha S.
Well done. That comes my first answer, my dear bacha. And that is where it comes to this part. If F2 is equal to F1, that means the condition when gamma L is equal to 3 times of gamma S, it remains at the same level. Do we understand this?
Yes, sir.
Now, once you know this, now you can tell me when it will go down and when it will go up. Tell me, when does it go down? When does it come up? This is simple common sense, bacha.
When F2 is greater than F1, the body goes downwards.
When F2 is greater than F1, the body goes down. Now this is F2 and you also already know what is F1. When will F2 be greater than F1?
When gamma L is greater than 3 alpha S.
When gamma L is greater than 3 alpha S, that is the condition. Yes, when it goes down, if you have understood the condition when it goes down, the reverse of that condition becomes when the body moves upwards. And when will the body move upwards?
When gamma L is less than 3 alpha S.
When gamma L is less than 3 alpha S. Now tell me, one of these things is definitely almost impossible. Which of these three conditions is definitely almost impossible? Which condition is almost? In fact, to tell you very frankly, only one of these conditions is possible practically. What is that one condition which is possible practically in most cases?
Gamma L is greater than 3 alpha S.
In most of the cases, beta, your gamma L is always greater than 3 times of gamma, 3 times of alpha S. So in most of the cases, only this case will happen. Do we understand this? Because I've told you gamma L is very, very large compared to gamma S. This 3 times alpha S is nothing but gamma S. Do we understand this?
Yes, sir.
So gamma L is always very, very large compared to gamma S. So in most of the cases, only case number 1 will happen. It will always move downwards. Do we understand this?
Yes, sir.
Anyone has any doubts on this? Please let me know.
No doubt, sir.
So this is what I had to make you understand, and I hope that this point is clear to all of the students in the class. I hope you understand this.
Yes, sir.
And this is a table that comes for you straight from my heart. And this table spells it out very nicely. Can someone read the first line, the first point? Can someone read the second one? And can someone read the third one? And now it will start to make sense. What is game number 1? What is line number 1? Tell me.
Gamma L is greater than gamma S.
So gamma L is greater than gamma S. Gamma apparent will be greater than 0. Change in volume apparent will be positive. And what will happen in this case?
Level of the liquid in the vessel will rise on heating.
So this is another way of understanding the same thing. When you have a liquid in a beaker, the level of the liquid always rises. So this condition and the condition where what we have done are almost similar. Do we understand this?
Yes, sir.
If, and this will not happen, if gamma L is less than gamma S, this will not happen. The level of liquid in the vessel will fall. This doesn't happen. Did I tell you that? Yes or no?
Yes, sir.
The same condition is there for a body floating in a liquid and whether it will go down or go up. Do we understand this? Can you relate the two cases now together?
Yes, sir.
They might look a lot different, but actually, are they different? No, they are not different. They are coming from the same phenomena. Do we understand this? And the third case, gamma L is equal to gamma S, the level will remain same. Both of them, three of them look different from the case that we have done just now, but they are same. This is what physics is. That is how you relate things with each other. Do you understand this?
Yes,
So you
sir.
understand one thing, and that will make you understand a totally different thing, which might look totally different, but the concept is same. That was all about expansion of liquids, and we go on to this. And very important condition, you will never find this in any of the books that you will ever encounter in your preparation. And just note this thing down, because if a question ever comes on this expansion of gases, you just need to write the answer, because you will not get a numerical on this probably. Expansion of gases. Gases have no definite shape, therefore gases can only have volume expansion, just like liquid. Since the expansion of a container is negligible, so we are taking that the container is not going to expand. Therefore, gas only have real expansion, because even if you heat up very slowly, the gas expands tremendously. So we neglect the expansion of the vessel. Do we understand this?
Yes, sir.
We have two types of expansion of gases: coefficient of volume expansion, coefficient of pressure expansion. The coefficient of volume expansion is delta V by V divided by delta theta. The final volume will be this one. The coefficient of pressure expansion is delta P, change in pressure divided by the original pressure divided by the change in temperature. Final pressure will be like this. And remember this very important condition for an ideal gas. The coefficient of volume expansion and coefficient of pressure expansion, they both are equal, and that is equal to 1 by 273.15. Actually, degree per Celsius. Do we understand this? 1 by 273. You must have heard this term before. We'll be dealing with a lot of gases, with ideal gas equation and this and that in the coming lectures. This is just for your knowledge that if a question comes on volume of coefficient of volume expansion of a gas and coefficient of pressure expansion of a gas, and how are these related to each other for a perfect gas, ideal gas, this is what you answer. And this is where I finish my class. We are done with the expansion. We are done with thermal expansion. In the next class, we'll move ahead with the next topic. And the next topic is?
Expansion of gases.
We are only done with expansion of gases, bacha. This is what we need to do in expansion of gases, because entire gases will be dealt in the next chapter, not this one. The next topic is, what is the next topic? Calorimetry. Measurement of heat. Calorie. Unit of heat. Metry. Measurement. Calorimetry. Measurement of heat. Measurement of calorie. Measurement of calorie is measurement of heat. That is the next chapter. We'll be dealing with calorimetry in the next chapter, in the next class. If you can, if you get time out of your busy schedules, please go through this class once again. See what we have done in this class, and if you get enough time, please read about calorimetry so that we can finish that part in one class. That is what I intend to do in the next class, that I want to finish the entire calorimetry in one class or maximum 2 classes. That's it from my end. I hope you love this class, and please work on what suggestions I've given you. These are suggestions that will help you in performing better in your exams. Take care and have a nice day. Bye bye.